Welcome to Electronics Techie. So in this video, we discuss about parity generator. So in real-time applications, when you want to send the data from sender to receiver, you have to check whether the data is correct or not. So for that purpose, we use parity. So how you know the parity means? So it is a simple overview for it. So parity generator is how you can use in the sender and receiver part. Means if you want to send some data like from transmitter to receiver. So the data is in like digital format 1010 like that. So transmitter know the data, but receiver don't know whether the data what is the data the transmitter will send. So how it going to communicate means, so if the data the transmitter say how many number of ones are there. So if it contains even number of ones, so it is even parity. So if it contains odd number means 110, like if contains odd number means there is a 3 ones, so 3 is an odd number, so it is an even parity. So if it is even parity, so extra bit is added like 0. If it is odd parity, so extra bit is added like odd parity. So like that you can represent like that. Means if you get the output as 0 means if you get output as 1 means, so if it is even parity, if it is odd parity. So for it is the simplest way. Number of ones is even number means it is an even parity. Number of ones is odd number means it is an odd parity. So there is another method. This is 0 and 1. How you get 0? 0 and 1 is means I say that. So now see 1 0 1 0. You know that XOR operation. So 0 1 1 0 1 1. So it is our truth table. So for 0 0 combination we get 0 0 0 1. So it is our XOR get truth table. So now what we are going to do means 1 XOR. So this 0 XOR 1 XOR 0. So whatever the data, so we have to XOR in between the each and bits. So for 1 XOR 0, so the combination is 1. 1 XOR 1 XOR 0. So the remaining will be written here. So again 1 XOR 1 is 0 XOR 0. So 0 XOR 0 is nothing but 0. So it is an even parity. So you can say either even number of ones it is an even parity, other it is another process. So for writing Verilog code we use this second process. So now we are going to write the even parity, or whether the parity is a even parity or odd parity, the parity generator in this code. So we have to start the Verilog code with module and end with end module. So we can write the parity generator as a module name as parity underscore generator. It is our module name. So whatever it is a module name. So whatever the input you have to give the data. So what is our output? So parity. So how many bits you get? You get only 1 bit. But input is you can take any number of bits, 4 bits, 5 bits, 6 bits, 7 bits, 8 bits. So here in this Verilog code I consider 8 bits. So 0 to 7 is nothing but 8 bits. So I consider 8 number of bits. So it is the data input. So that's why I represent with data underscore in. So it is output port. What is our output port? Parity. So what is the output we get? It is a 1 bit. So that's why I represent it with only parity, means 1 bit. So outputs are represented by output keyword and inputs are represented by input keyword. So now we can close the braces and end the line. So now again by using data flow modeling we use assign keywords. So why you use assign keywords? We have to assign the values of LHS side to RHS side to LHS side. So what you are going to do? So here we have, if you want to done the XOR operation in between the every bits in the data. So it simply represented like cap. What is the variable you take input as? So data underscore in. So means it is a redundant operator. Redundant operator is nothing but, so whatever the data you have to perform the operation between the every individual bits. So we can take 1 0 1 1 1 like that. So in between every 2 bits we have to perform this operation. So what is the symbol we have to represent it here? So we perform that operation. Here we consider XOR gate symbol. So XOR gate symbol is like our cap. So we have to perform the XOR operation by between the 2 digits. So that final value is assigned to the parity variable. So nothing but it is our output. So by using this output you said that whether it is an even parity or odd parity. So you can stop with end module. So we have to go into look the test bench code. So how you go to look the test bench code? It is also same like design code. So it start with module and end with end module. So parity underscore generator underscore TB is our module name. So inputs are represented with reg data type. So outputs are represented by y data type. So parity underscore generator is our design code module name. So it is our design code module name. So we have to instantiate and connect the 2 modules here by using this instantiation. So Teju is our instance name. So we can represent it by any name. So no need to mention particular name. So we have to remember that it not should be any keyword. So it is a port connection. So we already discussed about port connections. Port connections are by name and by order. So you mostly prefer by name, so you can reduce the confusion and any misconnections like that by using port connection by name. So it is our initial block to represent the input values. So now if you want to take different input values to calculate the output, so this will be done in the initial block. So initial block, what are the variables we take? It must should be in reg data. So that's why I represented input port as reg. If there is no initial block, so you simply represent inputs also with reg or net data type. Because of initial block only, we represent the input ports with reg data type. So these four lines are used for a waveform generation in EDF playground. So for generating EDA playgrounds, for generating waveforms in EDA playground, you want these four lines. So and with AND module. So final our waveform is looks like this. So if you want to know the particular values here, so you have to use this scale and double tap on this scale. What is the cement color scale is like that. So these values are represented here. So 91 means it in hexadecimal format it represented here. So 1 is nothing but, so you can represent it with by 4 bits. So 0001. So 9 is nothing but 1001. So here we can see, so it is our 0 index, it is our 7th index. So you can come from bottom. So 0 index to 7 index. 1000. So 100, 1001. So 1001. So how you get it is our there is a simple formula. So there is a odd number of ones. So it is an odd parity. So odd parity is represented by 1. So here we can observe it is in 1. So like that we can verify whether it is an even parity or odd parity. So it is about the parity generator. Like this we can know that it is even parity or odd parity. So I think it's clear. So if you have any doubts, you can comment it, and thanks for watching. If you have any doubts about single line also, you can comment it, so I can clear. I try to clear that. So until then, bye.